Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 194. Day 194, we are in the process of solving word problems from day 101 through 200, and today is our 94th day of solving a word problem. The problem for today is already on the blackboard. I'm going to read it to you. It says the difference between, the difference between two numbers is 26. The difference between two numbers is 26. So we are told that we have two numbers, one is greater than the other obviously, and the greater number is 26 bigger than the smaller one. The difference between the two numbers is 26. Then we are told further that if you were to add 6, if 6 is added to the smaller number, the result will be half the greater number. So if you were to add 6 to the smaller number, what we will have on our hand is some quantity which equals half the greater number. That's all. I want you to pause the video. I want you to solve it yourself, and once you have the answer, you can resume it and then compare your work against the work that we will do together. Okay? So here's the solution. Let's pretend that the smaller number is S. S for small number. If that were the case, if S is the quantity that represents a small number, then that implies that the greater quantity, the greater number must be what? Must be 26 more than the small number. Must be S plus 26. Why? Why does the greater number have to be 26 more than the small number? Because we are told that their difference is 26. We are told right there that their difference is 26, which means their difference is 26. Which means if a small number is say 5, the large one would have to be 5 plus 26 or 31. If a small number happens to be 10, the large number would have to be 36, 10 plus 26. If it turns out that the small number is 1, the large number would have to be 27, 1 plus 26, because we are told that their difference is 26. So that's that. That's all. Now all we have to do is read the next sentence. So this part that we just did came from the first sentence. Now we do the second sentence. The second sentence tells us that if we were to add 6 to the small number, this is the small number, here is our small number. If we were to add 6 to it, then the result will be how do we translate that into the language of algebra? The result will be, or the result was, or the result must be, or result is going to be, or this is this, or that this was that, or that will be that. All of those things are translated in the language of algebra, in the language of mathematics, as an equal sign. The result will be, there we go, the result will be what? Very simple. Very simple indeed. What will the result be? It will be half the greater number. Oh, this is the greater number. S plus 26. S plus 26 is the greater number. The result is going to be half of that. If we were to take our small number and add 26 to it, if we were to take our small number and add 6 to it, the result will be the greater number, which is S plus 26, times half, or half of the greater number if you like. That's it. That's all. As I always told you, the most important part, the most important ingredient, the most fundamental element of solving an algebra problem is making sure that you have the right equation to work with. That is the most important ingredient. As long as you have the right equation, the rest is downhill. So let's get rid of this 2 from the bottom. How do we get rid of this 2 from the bottom? Multiply both sides of the equation by 2. Multiply this side by 2. Multiply that side by 2. So that takes care of that too. Let's open the parenthesis. 2 times s is 2s. And 2 times x is 12. And here we have s plus 26. Let's get rid of this s from this side by subtracting s from both sides of the equation. So here we have positive 2x, here we have positive 2s, and here we have negative s. 2s minus an s will give us an s. Here is our equal sign. Here we have a positive s and a negative s. They cancel out. Obviously that was the whole point. We need to bring the 12 to the other side. How do we bring this positive 12 to the other side? Well, by the time the positive 12 gets to the other side, the positive 12 turns into a negative 12 like this. Because we need to subtract 12 from both sides. And now this 12, we have taken it, we have picked it up and put it on the other side, and by virtue of doing that, it changes the sign. Positive 12 becomes negative 12 because in order to get rid of this positive 12, we need to subtract 12 from this side. And if we were to subtract 12 from this side, we must do the same on the other side, otherwise this equation will no longer hold. For an equation to hold, whatever you do to one side of the equation must be done to the other side. Otherwise, it will no longer be an equation. Otherwise, the two quantities will no longer equate each other. An equation is so called because the two quantities on the left hand side and the right hand side equate each other. I know I'm being ridiculous. I know I'm pointing out the bloody obvious, but anyway. So now we have a positive 12. Here we have positive 12. Here we have a negative 12. So they cancel out. And 26 minus 12. How much is 26 minus 12? How the hell do I know? I know 26 minus 10 is 16. So 26 minus 12 must be 14. That's it. That's your S. I'm just bringing it closer so it's not a mile away. And for those of you who are hell bent on metric system, so that it's not a kilometer away. That's it. The small number is 14. If the small number is 14, the large number, which is s plus 26, must be 14 plus 26. 6 plus 4 is 10, which is 0, and then 1 goes here, 30, and then 40. Voila. So it turns out that the large number is 40. The large number is 40, and the small number is 14. And that's all. That's all there is. Now we're going to quickly verify that answer by doing the work here. So we have two numbers here. We have two numbers here, 14 and 40. The problem, and of course, as you can see, the difference is 26, which is where this comes from. If we were to add 6 to the small number, what we get is 20, which turns out, if we were to add 6 to the small number, the result will be half the greater number. There you go. If we were to add 6 to the small number, what we have is a quantity which is half the size of the larger number. That's it, we're done. That's all there is. What I'm going to do now is redo the problem. Listen carefully and understand why I want to redo it, because I want you to understand that there is not just one way of looking at the world. Different people look at the different things, same thing rather, not different things. Different people look at the same thing with different point of view. Half the people, half the mathematician, half the people who do the algebra, when you give them this problem, will sit there and solve the problem in this manner. They are looking at the world from the point of view of the small number. So this problem is solved from the point of view of the small number. In other words, this solution is using the small number as a point of reference. Where should we make a point of it? You see, it started out we started out by saying let's pretend that this small number is S. In other words, our center of universe was, the small number S. And we ask ourselves, how did the large number compare to this small number? And it turns out the large number was 26 more than that. We could have looked at the world from the point of view of the large number, the greater number. And we could have asked ourselves, how does the small number compare to the large number? We're going to do that now. We're going to redo the problem by using the greater number as a point of reference. Here we are using the small number. Here, small number is used as a point of reference. Now I want to redo it and use large number as a point of reference. Okay, I'm going to get out of the frame for about 5 seconds because I know I keep getting in front of the blackboard and cannot see it. As a matter of fact, I'll be right back. Just give me a second. I'll be right back in 2 seconds. Well, I'm back. It gave me perfect time to go fetch my tea, which I had left it on my desk in the other room. Voila. Let's redo it. We need to erase everything. Now we're going to do the same problem by using the greater number as a point of reference. And of course the answer is not going to change, the answer is still going to be the same. We're going to find that the small number is 14 and the large number is 40, obviously. Just because we're using a different method, it doesn't change the answer. And if it did, then something is wrong. So here we go. So we are using here the greater number as a point of reference in this solution. So here is our solution. Let's pretend that the greater number is G. In this solution I'm calling greater number G, letter G. I'm designating it with the letter G, G for greater. Don't use X and Y, don't use bloody X and Y, because then you have to go around memorizing which one was greater and which one was smaller. If you just say let the greater number be X, then you're going to have to remember throughout the entire solution that X represents the large number and Y represents the small number. Why? Just use G, G for greater. Therefore, or rather you could say this implies, if that is true, let's pretend G is the greater number, that would imply that the small number, this implies that the small number must be 26 less than G. Why 26 less than G? Because we are told that the difference is 26. If the difference is 26 and G is the large number, the smaller number, whatever the hell it is, got to be 26 less than that. And we're going to write that as G minus 26. Voila. And now we set up our equation. Our equation tells us that if we were to add 6 to the small number, this is our small number, G minus 26. So G minus 26, that's a small number. And if we were to add 6 to it, or better yet, let's write the equation properly first. Small number plus 6, we are told, this quantity, the small number, if 6 is to be added to the smaller number, the result will be, that's our equal sign here, the result will be, that's the equal sign, the result will be what? Half the greater number. Well, there is your greater number. This is our greater number. The greater number in this solution is designated with letter G. and we'll have half of that. Voila, that's it. Now what I'm going to do is, instead of writing a small number, we're going to actually write down what the small number is. Small number is g minus 26. So let's replace this thing with g minus 26. G minus 26 plus 6 equals g over 12. Minus 26 and a plus 6, it becomes g minus 20 equals g over 2. We need to get rid of this 2 from this side. Let's multiply both sides of the equation by 2. Do not, for Christ's sake, do not simply say let's multiply by 2. Students have this nasty habit because they are so lazy. If I ask them what are you going to do now, they simply say multiply it by 2. No, we're not multiplying it by 2. You have to say the whole thing. Let's multiply both sides of the equation by 2. We cannot simply just multiply g over 2 by 2. We cannot just take one side of the equation and multiply and go willy-nilly doing things to it. Whatever it is that you do to one side of the equation, exact same thing must be done to the other side. Otherwise it will no longer be an equation. You will violate the equation. Do you understand? Whatever that one does to one side of the equation, one must do the exact same thing to the other side. Therefore, one has to say, let's multiply both sides of the equation by 2. As a matter of fact, I'm going to put it in a red pen so you can see that the both sides of the equation are indeed being multiplied by 2. Voila. So that takes care of this too. So there is your g. 2 times g is 2g, and 2 times negative 20 will give us negative 40. Let's subtract g from both sides, so we get rid of this g. Subtract g from here, subtract g from here. I really do not know how low you can read in the blackboard. I'll check that in a second. So here we have positive 2g and here we have negative g. Positive 2g and a negative g gives us g. Let's add 40 to both sides so that we get rid of this thing, negative 40 from this side. 40 here, 40 here. In other words, we want to bring this 40 to the right hand side. This negative 40, by the time it is brought to the right hand side, the negative 40 is going to become positive 40, like this. Because how do you get rid of this negative 40? By adding positive 40 to this side. And if we add positive 40 to this side, we must add positive 40 to that side. Notice how I said it, add positive 40. That's how you have to say it. Because you could add negative 40. You can't just say add 5. If you want to be precise, you have to say add positive 40 or add negative 40. Do you understand? You can add negative 40, and if you're adding negative 40 to something, you're just subtracting 40 from it. But that's how you speak in the language of mathematics. If someone says let's add negative 3, well, let's add negative 3 is same as saying subtract 3 from it. Do you understand? So, negative 40 and a positive 40. This negative 40 and a positive 40, they cancel out. And here we have a positive g and a negative g. They cancel out, obviously, which is exactly why we did it. And we end up with this 40 right here, this 40. And here is g. I'm going to bring it closer so that it is not sitting a mile away. Or for those of you who are hell-bent on using the metric system, so that it is not a kilometer away. I know we did that just a little while ago. But anyway, there you go. That's your g. Greater number is g. If the greater number is g, then the smaller number, we just found that the greater number is 40, which is exactly what we had before. If the greater number is 40, then the smaller number, we are told, we know, is g minus 26. So it's 40 minus 26. 40 minus 26 better be 14. And of course it is. That's your small number right here. The smaller number, that's your small right there. That's all. We are done. So we did it in 2 different ways. We took our time. I will go at a very leisurely pace. We are not in a hurry. We want to learn. We don't want to solve a problem. We are not here to solve a problem. We are here to learn how to solve a problem. 2 different things. Take your time and enjoy it. Just learn it properly. Do you understand? I know I did say enjoy it. I know. Learn it properly. Nobody's timing you. Okay. I'll see you tomorrow on day number 195. Alright? Bye now.